Hello students, welcome to my class again. Today we'll do some organic conversions. Okay, I have taken a question from your NCERT textbook. Question number 10 point. Question number 10 point is 19. Here we'll do some organic conversions. ইয়াত আমি কি কৰিম অৰ্গেনিক কনভাৰ্সন কিছুমান কৰিম এটা যৌগক আন এটা যৌগলৈ আমি কেনেদৰে ৰূপান্তৰ কৰিব পাৰো সেই কামটো ইয়াতে আমি চাম the first is question is propane to propan 1 all আমি propanol পৰা propan 1 all বনাব লাগে we have to prepare propan 1 all from propane C CH3 CH double one CH2 this is propane now if we react propane with HBR in presence of peroxide what will happen we will have CH3 CH2 CH2Br. This is 1 bromo propane. Now we will react this compound with aqueous potassium hydroxide. This will give us CH3 CH2 CH2OH. So starting from propene we can prepare propan 1 all in this manner. Okay. There is another alternative method. In that method, what is done? Propene is treated with diborane in the first step, and in the second step, it is oxidized by alkaline hydrogen peroxide. In this reaction, we will get propan 1 all. So starting from propene, we can have propan 1 all by two methods. This is method 1, okay, and this is method 2. Now come to the next one, number 2. Ethanol to but1-ine. This is ethanol CH3CH2OH. Treat it with say HI. We'll have CH3CH2I iodoethane. Then this compound will be treated with sodium acetylide. Okay, sodium acetylide. We know that terminal alkynes are acidic. So hydrogen in this carbon, terminal carbon means the carbon containing the multiple bond may be replaced by a metal ion. Now what will happen? CH3 CH2 C triple bond CH NaI this will be lost here in this step. Sodium iodide will be lost. This reaction is discussed in your alkyl halide chapter. Okay, so sodium iodide will be lost, and as a result, you will get this compound but1-ine. Then come to number 3. 1 bromo propane to 2 bromo propane. Okay, CH3, CH2, CH2Br. This is 1-bromopropane. Allow this to react with alcoholic potassium hydroxide solution. What will happen? There will be dehydrobromination, loss of hydrogen bromide. So this Br and a hydrogen from beta carbon will be lost. As a result, there will be a double bond between these two carbons. So we get propene. Now this propene will be treated with HBr. What will happen? There will be addition of HBr to propene according to Markovnikov's rule. So you will have this product. So starting from 1-bromopropane, we can have 2-bromopropane via propene. Okay. Come to number 4. Toluene to benzyl alcohol. Toluene to benzyl alcohol. You know what is toluene? Toluene means methyl benzene. This is toluene. Allow it to react with chlorine in diffuse sunlight. What will happen? You will get CH2Cl, benzyl chloride. Now carry out alkaline hydrolysis process. Okay, this is a halogen. In alkaline hydrolysis, what will happen? That halogen will be replaced by hydroxyl group. So starting from toluene, we can prepare benzyl alcohol. Okay. Next, number 5. Benzene to 4-bromo-nitrobenzene. See, we have to convert benzene to 4-bromo-nitrobenzene. 4-bromo-nitrobenzene. This is benzene. React benzene with bromine in presence of ferric bromide. You will get bromobenzene. Now bromobenzene will be treated with a mixture of concentrated HNO3 and concentrated H2SO4 at elevated temperature. Bromine is an orthopara directing group, so the incoming electrophile, that is the nitro group, will enter either to this position, ortho position means position 2, or to this position, para position, that is position 4. But para substitution is usually the major substitution. So we'll have this compound. This compound has the major product. Okay. Suppose you are asked to convert benzene to 3-bromo-nitrobenzene. In that case, nitration should be done first. Nitration should be done first. Because nitro group is meta-directing. So incoming electrophile will be oriented to the meta position. Then come to number 6. Benzyl alcohol to 2-phenyl ethanoic acid. 2-phenyl ethanoic acid. Okay. See, this is benzyl alcohol. because hydroxyl group is attached with benzyl position. This is benzyl alcohol. You are to prepare 2-phenyl ethanoic acid. Okay. So treat it with SOCl2. Okay, thionyl chloride. What will happen? We have this hydroxyl group will be replaced by chlorine. Now treat it with potassium cyanide, alcoholic solution of potassium cyanide. There will be a nucleophilic substitution process here, and as a result of nucleophilic substitution, we will get CH2CN. Okay. We know that cyano compound on hydrolysis gives carboxylic acid. So if you hydrolyze this compound, the CN group will be converted to COOH group. See, 1, 2, this is ethanoic acid, but at position 2 there is a phenyl group. So this is 2-phenyl ethanoic acid. Okay, 2-phenyl ethanoic acid. Then come to number 7. Ethanol to propane nitrile. CH3CH2OH. This is ethanol. So PCl5 reacts with this. You'll get CH3CH2Cl. Okay. Now treat potassium cyanide. CH3CH2Cn. This is propane nitrile. Okay. Then number 8. Aniline to chlorobenzene. Aniline to chlorobenzene. What is aniline? Aniline means amino benzene. This is aniline. Treat aniline with a mixture of NaNO2 and HCl at low temperature 0 to 5 degree centigrade. Keep about. You will get benzene diazonium chloride. This process is called diazotization. So this is benzene diazonium chloride. Starting from this, we can produce chlorobenzene either by Sarma reaction or by Gattermann reaction. Okay. So in Sarma reaction, what is done? It will be treated with CuCl in presence of HCl. This will give you chlorobenzene. Then come to 9. Okay, 9. 2-chlorobutane to 3,4-dimethyl hexane. 2-chlorobutane to 3,4-dimethyl hexane. See, CH3CH2CH3HCl 1, 2, 3, 4. At position 2 we have chlorine, so this is 2-chlorobutane. You carry out Wood's reaction. Treat this compound with sodium in dry ether. Keep about here CH3CH2 CH CH3 CH CH2, CH3, CH3, 1, 2, 3, 4, 5, 6. This is hexane. At position 3 and 4, there are two methyl groups. So this is 3,4 dimethyl hexane. Now come to 10 question. 10. 2-methyl 1-propene to 2-chloro 2-methyl propane. See, 1, 2, 3, this is propene. At position 2 we have methyl group, so 2-methyl propene. If you react this compound with HCl, addition will be according to Markovnikov's rule. Positive part of the reagent is H will add to this carbon. Negative part is Cl, this will add to this carbon. So this will give you CH3C, CH3Cl. This one. This is 2-chloro 2-methyl propane. 2-chloro 2-methyl propane. Okay. Come to the next. Ethyl chloride to propanoic acid. Ethyl chloride to propanoic acid. Okay. See, CH3CH2Cl. This is ethyl chloride. Ethyl chloride has 2 carbons. Propanoic acid will have 3. So you have to increase 1 carbon atom. This can be done by introducing cyano group. So treat it with potassium cyanide. You will have propane nitride. Now carry out acid hydrolysis. On acid hydrolysis, cyano group will be converted to carboxylic acid group. Next one. But1 into N-butyl iodide. But1 into N-butyl iodide. This is but1 in N-butyl iodide. Iodine should be attached with this carbon, carbon number 1. So the addition reaction should be anti-Markovnikov's addition. But we all know that anti-Markovnikov's addition is possible only with HBr, not with HI. So first, react this compound with HBr in presence of peroxide. What will happen? There will be anti-Markovnikov's addition. You will get 1 bromobutane, means N-butyl bromide. Okay. Now, from any alkyl halide, we can produce iodide, alkyl iodide. How is it possible? Simple. You have to treat it with sodium iodide in acetone. In this case, you will have this. Okay, one iodobutane or N-butyl iodide. Then come to the next. 2-chloro-propane to propan 1 See, CH3, CHCl, CH3. This is 2-chloropropane. Okay. Carry out dehydrohalogenation. This will give propene Is it not? You'll get propene. Now propene will give you propanol by means of hydroboration oxidation reaction. This reaction is already given. So propene on hydroboration followed by oxidation will give you propanol. Come to the next. Isopropyl alcohol to iodoform. Isopropyl alcohol to iodoform. This is isopropyl alcohol. Okay. See, an alcohol which has a CH3CHOH type group means an alcohol which on oxidation can give methyl ketone group, CH3CO group. This is a secondary alcohol. So on oxidation this will give you ketone. That ketone will have a group CH3CO, okay, that is called methyl ketone group. So such a compound when treated with halogen in presence of sodium hydroxide solution, haloform is produced. Okay, if we use iodine, then the reaction will be called iodoform reaction. So in this case, iodoform will be produced. Isopropyl alcohol on oxidation will give acetone. Isopropyl alcohol or acetone when treated with iodine or iodine and sodium hydroxide solution will get iodoform. This reaction is called iodoform reaction. Iodoform reaction. Okay. Come to the next. Chlorobenzene to p-nitrophenol. Chlorobenzene to p-nitrophenol. See, this is chlorobenzene. This is an aryl halide. Aryl halide may sometime undergo nucleophilic substitution under very specific conditions. Say when aryl halide, say chlorobenzene, is fused with sodium hydroxide at a very high temperature, 623 Kelvin, and a very high pressure, 300 atm. Okay, then what will happen? Sodium phenoxide, this will be produced. On hydrolysis, this will give you phenol. This is phenol. Now, that phenol will be treated with dilute HNO3. On treatment with dilute HNO3, phenol will give you a mixture of ortho, nitro and para-nitrophenol. Para-nitrophenol is the major product. Okay, come to the next. 2-bromopropane to 1-bromopropane. This is 2-bromopropane. You carry out dehydrohalogenation reaction to prepare propene. This is propene. Now carry out addition of HBr in presence of peroxide. according to anti-Markovnikov's rule. Okay, this will give you. So starting from 2 bromopropane, we can prepare 1 bromopropane. Next, chloroethane to butane. This is simple. Chloroethane. This is chloroethane. If you carry out Wurtz reaction, that is treatment of chloroethane with sodium in dry ether, this will give you butane. Okay, chloroethane to butane. So this reaction is Wurtz reaction. Come to the next. Benzene to diphenyl. Benzene to diphenyl. This is benzene. You react benzene with chlorine in presence of ferric chloride. Here, this is chlorobenzene. Now treat chlorobenzene with sodium in dry ether. This reaction is called Fittig reaction. Fittig. Okay. You will get this compound. This is diphenyl. Diphenyl. Next, tertiary butyl bromide to isobutyl bromide. Tertiary butyl bromide to isobutyl bromide. Okay. Look, this is tertiary butyl. This is tertiary butyl bromide. Carry out dehydrohalogenation reaction. What will you get? You will get this compound. Because this bromine and a hydrogen from this carbon will be lost. There will be a double bond between these and these two carbons. What is this? This is 2-methyl propane. Now, from this, it is possible to prepare isobutyl bromide. Isobutyl bromide will be a compound where bromine will be attached with this carbon and hydrogen attached to this carbon. So, if bromine is to attach to this carbon, you have to add HBr in presence of peroxide. Okay. In that case, this will be the product. 1, 2, 3, 1 bromo, 2 methyl propane, or this is simply called isobutyl bromide. Come to the last. Aniline to phenyl isocyanide. Aniline to phenyl isocyanide. Okay. This is aniline. It is an aromatic primary amine. An aromatic or aliphatic primary amine, when reacts with chloroform and alcoholic potassium hydroxide solution, isocyanide is produced. This is phenyl group. So this is phenyl isocyanide. This reaction is called carbylamine reaction. Okay, this much for today. In our later classes, we'll go for some other exercise problems. Okay.